We'll be learning about caching in cloud systems design. I'm Chris, cloud architect and founder of systemsarchitect.io and codeguides.io. I'll be guiding you through this journey. Caching belongs to the cloud performance domain. A cache layer is a fast store holding copies of frequently accessed data. It sits between a client and the slower system of record. When the data is there, you skip the database call entirely. The whole idea is paying for memory to avoid latency. Every cache trades freshness for speed, and that trade shapes your architecture. A cache hit is a request served from the cache. A miss falls through to the origin and pays full price. What is a cache hit ratio? Your cache hit ratio is the share of requests answered without touching the backing store. You push that hit rate from 50% to 90% and origin load drops fivefold. Reads from memory are commonly 10 to 100 times faster than disk-backed storage. Knowing this lets you cut latency and cost without rewriting the application. The simplest cache is an in-memory cache running inside your application process. Redis and Memcached are the two engines you will meet most often. Memcached is a plain key value store. Redis adds data structures, persistence, and replication. A per-node cache is fast. It gives every node a different view of the data. A distributed cache, or cache cluster, shards keys across nodes. All clients then share one view. Managed cache services run those engines for you. Elasticache on AWS, Azure Cache for Redis, and Memory Store on Google Cloud. Real systems cache in several places at once. Multi-layer caching runs browser, then CDN, then application, then database. Browser caching uses cache control headers, so the client never sends the request. A content delivery network caches responses at edge locations near your users. CloudFront as your front door, Cloudflare, and Cloud CDN each serve from hundreds of edge sites. Edge caching can cut a 200 millisecond round trip to under 30 for distant users. Every layer you add absorbs traffic before it reaches the layer below. Cache aside, also called lazy loading, puts your application in charge of the cache. You check the cache. On a miss, you read the database and write the result back. Only requested data is ever stored, which keeps memory usage small. The cost is that every first request pays the full slow path. How does read-through differ? A read-through cache hides that logic behind the cache client, which fetches from the origin on a miss and populates itself. Read-through keeps application code clean. Cache aside gives you control over what gets stored. Writes need a policy too, or the cache and the database drift apart. A write-through cache writes to both stores in the same operation. Data is never stale, and write latency becomes the sum of both writes. A write-behind cache, also called write-back, acknowledges immediately. It flushes to the database later. That absorbs bursts of writes at the risk of losing data if a node dies before the flush. Use write-through for orders and account balances. Use write-behind for counters, metrics, and session updates. Nothing stays cached forever, and two separate mechanisms decide when an entry leaves. A time to live sets a cache expiration. After that, the entry is treated as gone. Short TTLs of 30 to 60 seconds bounce staleness on data you cannot actively invalidate. Cache invalidation is the deliberate removal of an entry when the underlying data changes. Cache eviction is different. It happens when memory fills and something must be dropped. Least recently used, or LRU, is the usual default eviction policy. LFU, FIFO, and random are the alternatives. A cache is only as good as its cache key design. Your key strategy should include every input that changes the answer: tenant, user role, locale, version. Why be so careful there? Miss one and users see each other's data, while adding too many collapses the hit ratio. Object caching stores a serialized entity, such as a user profile. Query result caching stores the rows a query returned, keyed by the query and its parameters. A version prefix in the key lets you invalidate a whole class of entries at once. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. The dangerous failure mode is a cache stampede, sometimes called a thundering herd. A popular key expires, 1,000 requests miss together, and they all hit the database at once. Cache stampede prevention means locking so one request refills while the others wait. Cache coherence is the matching problem across nodes, two replicas holding different values for one key. Most caches offer eventual consistency rather than strong consistency. You accept a window of staleness. Cache warming preloads hotkeys after a restart so nobody pays for a cold cache. Performance is the headline benefit. Sub-millisecond reads instead of tens of milliseconds. Cost falls sharply because a cache node is far cheaper than the database capacity it replaces. Reliability improves when the cache absorbs a traffic spike your origin could not survive. Scalability follows since read traffic grows against memory rather than against your primary database. Operations get calmer. Fewer slow queries mean fewer alerts and less firefighting. Caching adds a second source of truth, and that is never free. Skip it for data that must be exactly correct on every read, like inventory at checkout. For write-heavy workloads, a read replica or a better index often beats a cache. If your problem is one slow query, fix the query first. Caching it just hides the bug. A cache you cannot invalidate is a bug waiting for a customer to find. Caching stores frequently accessed data in a fast layer so requests skip slower origins, whether that layer is an in-memory cache like Redis, a distributed cluster, or a CDN at the edge. Cache aside and read-through govern reads. Write-through and write-behind govern writes. TTL's invalidation and LRU eviction govern how long anything survives. Design your keys carefully. Measure your hit ratio and defend against stampedes, because a cache is a copy, and every copy can be wrong. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.